seniors know Dennis, but for the juniors, I would say, I would just introduce Dennis. Dennis is from Kenya. He's an assistant professor over there, right?
Yes.
He's working in a university in Kenya. I forgot that university. What is the university name?
Dedan Kimathi. Dedan Kimathi
University. Yeah. He
yes.
is in the applied statistics department now. What is that? It is
yes.
statistics department.
Yeah, applied statistics departments.
Yeah, applied statistics department. So it is exactly yes. good for our data science students. What data science yes. are doing is exactly applied statistics. It's not pure yes. Probability theory or nothing. Then you apply statistics for real problems. That is what data science is all about. Like, so yes. He will be very good resource person for our students, for the data science students. They are also teaching similar stuff. And yes. How this is only for juniors, like not juniors. How I know Dennis is Dennis did PhD with me in our department. He was in our department for 5 years. Almost 4 years now, or 3 years you were
yes,
here. Like.
Yes, yeah.
Yeah, he did PhD in our future studies department, now working in Kenyan University. Like, you might have heard he is inviting us to his country, like the university. And he says in his university, there's a scheme for exchange program, like you go there to learn something. If this corona was there, we could have even traveled there.
Sure, that is true.
There. And as he suggested, maybe we can have an international forum. Like now, every Friday we are having this talk. After starting it, never disrupted. I appreciate very much the effort of Dr. Prem Sengar. He is the one who took the initiative. He's very interested in these kind of aspects, motivating students, interacting with them. He's very good in that. Because of him only this is happening. Otherwise, this would not have happened. Okay, yes. About Dennis. Dennis did his PhD in our department, and I was asking him how did he come to know of our university? Why did he select our university, like Kerala University in particular? Then he was telling me there is an ICCR fellowship actually.
ICCR, yes.
Yeah, cultural exchange scheme. Yes. According to that, Indian government is giving fellowship to foreign students, and he applied for that. And they were given a list of universities in India. Like, he came to know this university. At random, he selected this university for his one option. Like. And yes. Finally, he landed in our department. Like. And to your knowledge, I would say that he is very good in R programming and statistics. Actually, I will tell that even I learned many R, or to this extent, I am comfortable with R, mainly because of Dennis actually, because we can learn, but when he, even before that also, we were doing a little bit of R programming, but he is into that actually. So whenever, when he was here, if I want something, I just ask Dennis, he will do. He will write the code, etc. And thereafter, we were also learning a lot from R. And he has published a very good paper during his PhD thesis, like in renewable energy. Dennis, the impact factor now, that 2021 impact factor is, now it is, the impact factor is more than 8. Yes. And when we published 4.5 or something, now the impact factor is 8. So he published a paper in wind energy. So we were working on wind energy. He published the papers on that, and so he's he's honoring them, I would say. And I request our students to interact. Our only problem with our students is that they won't interact. Right? I have to call by name, then only they will ask some question or make a comment. Just please feel free to make comments at least if you don't have questions or anything. Because Dennis is one of us, like like you, he was in our department for more than 3 years. Like he's very funny.
Actually, I say I am a Malayali at heart.
See, he says he's a Malayali at heart. Like, okay, okay. So this is I'll hand over the platform to Dr. Dennis.
Okay, thank you, sir. So thank you, sir, for the wonderful introduction. As you've been told, I was in Kerala from 2013 up to 2016 December. That was the time when I was doing my PhD, and sir, and it was actually a very wonderful moment. I learned a lot actually. I should say, actually, I normally tell my colleagues here, Kerala is my second home. So I learned a lot while I was studying there. So today I wanted, I didn't want to make this to be very formal, such that it's a matter of one way conversation or communication.
Right, right.
We say we are lifetime students, so we learn every day continuously. So when you learn something new, share with somebody else. We say that the only thing in life that increases when you give is knowledge. When you share knowledge with another person, you perfect it. So if it was a bank account, your savings would increase in terms of knowledge. And like when you withdraw money from an ATM, if you had 10,000 rupees, you withdraw 5,000, you remain with 5,000. So for knowledge, it's almost, it increases actually. So that's why we say, when you know something, share. Sah has been very good in that. He has shared a lot of information with us. And we are doing the same thing now also with our students here. So when Sai and Prem contacted me regarding this talk, then I said, why not? It's time also to share what I've learned in the field of time series. So maybe just as let me see if I can share something. So
Yes.
I hope you can view that.
Yeah, it is coming. Yeah, we can see that. We can see.
Ah, that's great. That's great. Okay. What I have here, it's not the conventional way of where we normally go through slide by slide. I wanted us so that we at least we discuss these things. So what I've done is I've put them in point forms so that we can discuss on these things. When we discuss, actually, it tends to improve the level of or our capability of understanding something or an idea. So let's go to the next slide here, whereby these are the 4 common questions we normally ask in time series, whereby someone can say, what's a time series? So as we can see here, just as per the name, being having some background in statistics, at least you know, this is just a series of data collected according to time. So the time component is very crucial when it comes to time series. So, and then now, once you've understood what a time series is, the next question that comes to mind is, where does it come from? So in our day-to-day activities, there is a lot of data that is being generated, be it from, let's say, hospitals, the data being recorded, let's say, during this COVID pandemic, the data being generated by the airlines, the data from the Reserve Bank of India, for example, on the forex rates, all that is time series because they are being recorded according to time. And when you talk of the time, it's at equal intervals. So, for example, let's say if it's the Bombay Stock Exchange, for instance, they continuously record how the stocks are performing in the country. Which stocks are doing very well, which ones are doing badly, which ones are not changing, they've remained constant. So all that is just an example of the time series data. So the next thing is yes, we have now the data. We've known what a time series is. You know where the data is coming from. Now the next question is, what do we do with it? So for instance, if you want to invest in stocks, but the biggest challenge is someone can say, what happens? Maybe suppose I buy stocks for Indigo, and then in the next few years, the shares might go down, then you lose. Because we have cases whereby, take for example, I'll give you an example in my country, whereby there was a company which was manufacturing the dry cells, the ones we use on our spotlights. In the past, they were doing very well when the level of electricity connection was very low. Because you can imagine, if there was no electricity connection, people would prefer using spotlights and the dry cells. The moment electricity penetration went deep into the villages, the company lost a lot. And as we speak now, they've closed their branches in Kenya. They've now moved to Egypt because it was no longer favorable. Because what would you expect, for example, let's say, if people have been relying on electricity, or let's say relying on the dry cells through spotlights during the dark, suddenly electricity is everywhere. Do you need the spotlight anymore? No. So those are the things as students in data science, we focus on, we look at the problem, and then once you've identified the problem, you look for ways how to solve it or how to solve them. So, and as it is right now, we no longer use the old ways to solve problems. With the advent of computers and laptops, the kind of problems you solve now is just within your room. Like just right now, you're at home. You can solve so many problems. Take, for example, if you were to model the COVID data, you study the wave. When is this wave likely to spike? When is this wave likely to go down? Then if you are able to develop models that can capture that, help us in forecasting. So if we can have pretty good forecasts, it can help the governments to plan accordingly. Take for instance, right now, maybe in India, the COVID situation could be maybe it has already reached the peak. Now it's coming down. So you expect now the situation to be better for the next maybe a month or two, and then another wave again will come. You see that? So can we be able to model this data? As much as maybe the data could be very limited, because now this is a pandemic, it's a new pandemic. And there's this analogy or concept that statistical models have to learn from the past, where we say the models have to know the past so that they can forecast the future. So once we have this data, can we analyze this data? Can we try as much as possible to train the models well, so that even if it means if we are dealing with parametric models, these are the ones whereby we have to estimate parameters and we make assumptions out of them. Can we make the correct assumptions so that when we do the forecast, we will get reasonably accurate forecasts? Or even if it's not very accurate, at least it can guide us. It can give us some idea on what is really happening. So that takes us to number 3. That is now what we need to do with it so that we can improve decision making. There's what we normally call in statistics, we call it informed decisions. If someone tells you, I'm deciding to do this, and then somebody else tells you, I'm going to have an informed decision. Informed means it's backed by some evidence or some kind of a model, so that by the time you are doing something, you've already, you have more facts. Unlike someone who do not have any idea. You're just told, do this, you just accept without knowing. A very good example of that is if you are, let's say, for example, let's use this example. Suppose you are to collect data on subjects, human subjects. We normally actually say when you are conducting research on human subjects, the component of ethics, you could normally call them the research ethics, must be considered. Whereby, if someone is willing to join, let's say, some research on maybe a COVID vaccine, for example. In research ethics, if that person decides to withdraw in the process, that person should not be denied to do so. So all that is information. So, and you see, to minimize such occurrences, if someone makes an informed decision or informed choice, you will experience less of such occurrences. But if you just tell someone, we are conducting research on COVID vaccine, you can just join. Then in the process, maybe there is a rumor that maybe the COVID vaccine can harm the body. Then people will withdraw in the process without completing the study. So these are the challenges. So with data and research from learning from the past data and past experiences, this analysis can improve actually the way research can be done and the expectation out of it. So, and then now the biggest thing is, yes, now we've known what can be done with this data. The next question that comes to mind is, how can we do it? Yes, everyone is having very good ideas, but how are we going to do it? So, and that those are the 4 questions I wanted us to ask ourselves today. So, for the component of what's the time series? Maybe someone from the data science class. What can you say about a time series? Somebody from data science? Someone from data science class?
Yeah. Interact with them. At least someone tell what is that time series. I think somebody has already done. Yeah, Vijay, please.
Yes, Vijay.
It's a sequence of data, like it's a sequence of data that occurs over a period of time.
Excellent, excellent. Thank you, Vijay, for that. So, just as you've put it very well, it is just a sequence of data that that has been collected according to time. So, one moment. So as we have there, just think of any data that is collected according to time. Be it, for example, let's say those cameras on the highway capturing information continuously. If anything happens, let's say, for example, you are captured overspeeding, that's time series data that you are collecting. So, but the biggest problem that countries normally face, I don't know if that's the case in India, whereby most of the countries in the world, actually, they've collected a lot of data. But data without use becomes useless. Because if you don't give room for, let's say, researchers to model the data, will it really help anyone? No. So the governments should be able to. There's something they've started in our country. They call it open data policy. But still, even with the policy, they are scared to share the data. You see such challenges. Eh? The policy is there, but they are still scared. So you go, like, for example, I have a student doing research on stocks. He's doing business analytics. So when he went to the stock market agency, then he was told you have to pay by company per year. So if you did for 10 companies, you have to multiply that. So if they tell you it is 100 rupees per company per year. So for students, can you multiply? If you need 10 companies for 10 years, you have to pay how much? The data science guys?
Yeah, 10,000.
If it is 100 rupees per company per year, you want 10 years for 10 companies. That will come to how much rupees? It's a brain teaser. It will be
A huge amount, right?
it's a huge amount. So you can imagine if that data is availed, and the researchers use that data to munch. There's this thing we normally call it data munging. Data munging, I want you to use the concept of a sugarcane. For a sugarcane, when do you get the best out of it? It's after chewing it. If you chew a sugarcane, you get the juice, which is the sugary bits. In data also, that's what we call now information. Because we say information is processed data. So what the governments have currently is data, which cannot, you can't do much with it unless you do the munch the data, extract some information out of it. A very good example is for the COVID cases in the world. If no modeling is done, then governments would be got flat-footed in terms of planning, whereby maybe suddenly we have the COVID cases increasing, and we are not able to. Maybe we didn't order enough oxygen tanks for the extreme cases of the COVID. So these are the things which tells us data is very crucial, and for the data scientists like you and data analyst, you are the only ones and the only hope for our governments to munch the data and publish. Because again, you know, we say, suppose I do research in my room and I don't publish it, then it is, we normally say it's as good as it was not done. If you don't give it out, it's like nothing was done. Because as it is, if you don't share your results, it's like there's no value being obtained out of it. So that's one area. I've given just an example of health, because now because of the COVID is a big disaster as we speak. We also have finance. Finance mainly, if you want to start for investing in stocks, then you have to model so that you see, if I invest today 10,000 rupees at Indigo, what will be my expected return by next year, for example? Or when you are modeling the data, you realize that there are some companies whose return will be quick. And there are those companies whereby the returns are very, very slow. So sometimes maybe you invest 1 lakh rupees and you want to get something out of it within 2 months. Yet maybe the return for that kind of a stock will take more than 1 year for you to make reasonable returns. So these are all situations that we come across. There's also a component of the environment. There's the component of the medicine. So the main thing actually when we are dealing with this, why do we analyze the time series, is mainly just to munch the data and extract meaningful information out of it. So whenever you say, you describe and summarize the data, at least now you are in the process of getting the information out of it. Because sometimes we collect the data, but the objective that you have when you are starting that, maybe that study or research, maybe it was just to check the trend. That data, you cannot say you've exhausted the information out of it. You've only captured one part of it, one component. So there are other facets to it, and you can extract also more information out of it. So the other thing is the one for fitting models and forecasting. You make the forecasts. And the one for the forecast, this is one which is very crucial, because now when it comes to planning purposes, it helps a lot. It helps a lot in policy and also in planning. And for time series data, we have the 4 components, whereby we have the era, the cyclic, the seasonal, and the trend. I'm sure the data scientists and the analysts have already done this, which is the easiest there in predicting. Somebody should try. if you were to predict one of those components, which is the easiest? Which is the easiest? Somebody to give it a try. Someone to give it a try.
Yeah. Tell. Tell something. Need not be correct. That is your guess.
Actually, you don't have to be correct. That's why we are here to learn.
Trend.
Yes, trend, you can get it accurately. Which other one?
Who said it? Who said that trend?
That was Sri.
Sri, is that? Yeah.
Yeah, Sri. Somebody else to tell us which one can you forecast accurately? Somebody? Data scientists and analysts are supposed to be outspoken because you'll be sharing information.
That is one major skill for the data analyst, like communication. Communication skill they value very much when you go to company, like because you are supposed to talk to your customers. If you do some good work and all, how do you communicate with the customers? They don't know science.
Excellent.
So, if I can talk like this, why can't you? Like,
yes.
I have to call by name. Then they will correct that.
And you see, online is the best thing. If it was physical, you say, I would have pointed your name. Right now, you are alone in the room. So even the seasonal components, we can predict reasonably well. The cyclic components. And then someone to distinguish for us seasonality and the cyclic. What's the difference? Seasonal and cyclic. Rajan. Let me call names so that people can talk.
I think data science, Anand or Prebin.
Anand, the attempt.
Right.
Yeah, just attempt.
Did you get the question? He was asking what is the difference between seasonal and cyclic, right?
Yes.
What's the difference? Seasonal variation and cyclic.
Or to make it simpler, let me say which one is a subset of the other one.
Sir, seasonal would be like it occurs every like the month or the holidays that we see every year.
Yes. And then cyclic?
Cyclic would be our definition of the period of time, I think.
No, in terms of variation, cyclic is the green one, right? So that is very slowly. Variation, fluctuation part is less. No, it won't fluctuate much. It is more smooth.
Yes.
Right.
Yes.
Seasonal is more fluctuating. It is short curves, right? No, very small curves, fluctuating.
Yes.
So which one will be easy to forecast? The one with the less fluctuation, right?
Yes.
If it is fluctuating, if it is oscillating, very difficult to predict. No, the less fluctuation is more accurate. Like as we said, trend is a straight line. We can even predict what will be the trend next. It is a straight line, so you know what will be the next value.
Yes, that is it. Actually, Sir has really helped. Sir has really helped you. You guys, where are you? So that is just like the way Sir has put it. Yes. Any other inputs? This is interactive. Don't take it to be very formal.
Yeah. I don't think I've heard. Or Prabin, you want to say something? Okay, go ahead.
Okay. It's okay. No problem. So just the way Sir has put it very well, the lesser the fluctuations, the better. So the cyclic component can easily be predicted as compared to the seasonal. Then when I was asking which one is can happen within the other one, just the way Vijay had answered, seasonality happens quite regularly. That for example, if you're dealing with stocks, for example, let's say the sales in the supermarkets, you would realize, let's say, if we go to Big Bazaar, for example, and then we ask them to give us their sales for the whole year, you'll realize that around functions or celebrations, people tend to buy more things. Then when there is no celebration, the sales might go down like that. And then that component will tend to repeat itself every year because of those events. They're being held every year. So they'll happen every year. So, but for cyclic, mainly, we normally say for cyclic, it's mainly the economic. We call it the economic cycle. Economic cycle is, in business, if you start a business today, you might start the business when the environment is very good. And that is when now, for example, let's look at this. When it's at the upper parts like this, the business is doing very well. Then there are times when there is, we call it recession. Recession is when the business starts going down. And then we have the depression here. Depression is when things have gotten to the worst. It cannot go any further. Just like what happened, let's say, during COVID for businesses. Then after that, we normally say after a down time, there is a time also to recover. So this stage, we normally call it the recovery stage. And then you go back to prosperity. So this economic cycle tends to repeat itself. So it can be after a long period of time, maybe more than 5 years, 6 years. But for the seasonality, it can even happen within a year. That's why you have, within the cyclic is a green one. That's why within the cyclic, we have seasons, just like the way we have them here. And this is actually very, very crucial. When we are modeling time series, it can be good. When you realize such a behavior in your raw data, then you might consider data transformation methods like decomposition. You can decompose your data. Because again, there is the component of error, the error term, whereby it is very hard to predict. There is this term you've been using quite often in class, I suppose. IID. What does IID mean? IID. We say the error terms are IID. Independent and identically distributed. So the error terms, and the reason why we are normally told when you sum the errors, they will sum to 0. It's because you'll be having almost same number of the positives and same number of the negatives. So when you sum them, they will cancel out. That's why we normally say the error terms, if you are to find the mean is approximately 0. So that's the main concept actually in time series. But we are not saying this should happen this way in any time series. Time series vary depending on the nature. If it's some economic time series, then expect economic cycle. If it is, let's say, COVID has also given us a new perspective of the waves. So if you are able to forecast the wave, the better for everyone in the world. Because now we'll be able to say, first wave happened between this month and this month. Then there was a downward period. And then the second wave aspect or the third wave aspect, then it will take this duration. Then the government can plan itself accordingly in terms of tackling the situation. Now, there is this thing, we normally talk a lot about it. In statistical theory, we normally talk of the IID. I've just shared that, whereby the data have nothing to do with each other. The occurrence of the first of a value, let's say the current value has nothing to do with the tomorrow's or yesterday's. So, but in reality, data tends to depend on each other. Take for example the stock prices. Today's or tomorrow's price fully depends on today's. So there is some dependence. And that is why in most cases, normally before we do analysis in time series data, we normally we call it detrending. You detrend. Then you analyze, and that is the main part you normally see in ARIMA, the I. So the I in ARIMA, for example, when you're fitting your data using an ARIMA model, it will trend the data and then fit it. So when it's through with the fitting, now it goes the reverse to give you the real observation that you had. And then there is the second component here. I want someone to tell us this one here. In statistics, we normally say large data sets are very good. But again, we are told sometimes it's not always the best. Any case study from a data scientist? Any case study? Why do we say this? Any reason why we say that? Any reason? Why do we say when you are modeling your data, more data is good, but at the same time we say not always. Let me give you a very good example. Suppose we have data up to pre-COVID, just before COVID, of let's say sales, for instance. What could have happened between, let's say, March 2020 and March 2021 to the sales? Any observation that you might be imagining could have happened during that period? Definitely, there's a lot of the data became more of chaotic. So if you've been receiving a lot of customers, for instance, then suddenly there's a lockdown. People can't go out that much. The sales will come down. So when they're dealing with such kind of data, you tend to find some outliers. And if there is something very terrible when it comes to modeling, it's the component of outliers. Because an outlier happens for a very short duration, and then it goes back to normal. Another very good example is if you find, for example, let's say, the attendance of students to a library, for instance. You normally find students at the beginning of the semester or the term, no one wants to go to the library. So if you are recording the number of students going to the library, then suddenly when the exam approaches, the number shoots. That's what we normally call the outlier, the extremes that happen within the data. And that is why in such cases, there is a concept we normally call it data imputation. There are two possibilities. Some people would say, just remove the outlier and do the modeling. Another person would say, but if you remove the data, you miss some information out of it. So it's better you impute. To impute data is to pick another value and replace the outlier with that value. For instance, you can consider the nearest neighbor. So if the nearest neighbors have been, let's say, 50 students, 60 students, then you can pick that one. Another person can say, let's consider the median. So you replace the outlier with the median. That's also another possibility. Another person would say, let's use the mean. But why do we say mean is not wise? It's not wise to use the mean. What could be the reason behind that? Why do we consider median as compared to the mean? Any reason behind that? Vijay?
Sorry, I don't know, sir.
Okay, thank you, Vijay. Anybody else wants to try?
Sir, due to
There's something.
extreme.
Yes, Shida. Yes.
Shida, go ahead. Tell. Shida, please.
Shida.
Extreme values.
Because of the extreme value. Excellent. Because we know when you find the mean, it's also affected by the extreme values. So it will also affect it. And that is why now there is something we normally call it a robust, when you're dealing with models, there's something we call it the robust model. That's a model whereby it can handle extreme situations. If your model can handle extreme situations fairly well, we normally talk of it as it being a robust. So the same thing with the median. Median is a robust measure as compared to the mean. So for example, if you go to an organization and then you ask for, let's say, the average salary of the staff or of the employees, then you are given the average salary in our company is maybe 50,000. But when you ask for the median, you might realize it is 20,000 rupees. So you see, so those are the two measures. If there is fairness, you would expect those two measures to be very close to each other. So if, for example, now you ask the salary, it's 20,000, it tells you there are a few people who are earning a lot compared to the majority. But when you took off the median, at least now it will eliminate the extremes and give where the majority are in the center of the data after sorting them from the smallest to the highest. So thank you, Shita. Then now we go to the main reasons. The main reasons why we study this is it depends. As I've told you, this one is the way you manage the data is dependent on your objectives. There are some companies, their concern is only the trend. Just to know whether this time will be doing very well as a company, or the direction is maybe going down. Then you do corrective measures, or the component of the turning points. This one also is very crucial. Take, for example, even the COVID cases. The turning points is how the data keeps on changing the direction. So, for example, when it goes, it increases, then suddenly now the wave comes down. We talk of it, that's a turning point. So we consider the resolution again matters a lot. How soon do the data change direction? Then we also look at, does it change quite often, or it takes some time for it to change? Things like that. Then the next part is, I've also mentioned this one. The main reason why we do the analysis is to understand the past. Because there is this saying which says you can only know where you are going if you know where you are. So the same thing applies to data. You can only forecast the future if you study the past. Some people also say the best way to predict the future is to create it. You create the past, and then now you have a certain future. But there are some other situations, like, for example, let's say the random components in the data, which is unpredictable. It's out of our control. Something like COVID. No one would have thought that COVID would occur. But suddenly it happened, and it has changed everything. So we consider that to be, that's a random component. It's a random source of random error. It's a source of random error. Now, Ramaswamy has said the comparison between two periods shall be done. Yes, that is it. Thank you. Thank you, Ramaswamy. That is true. And you get to learn better about the future if you model. The level at which you study your past guarantees the level of determination to the future, how well you can forecast the future. Then I have the next slides here. I wanted this to be interactive, but now data scientists have decided to be quiet. So an example, where does this come from? The time series data. Where does it come from? At least now everyone should be able to say something here. We are about to wind up. Don't worry. Yeah. Any example?
Yeah, tell one example each.
Airline data.
One example each. Yes, 3.
From airlines, right?
Airlines, yes, excellent. Thank you. Somebody else?
The global temperature data year-wise.
Yeah, the global temperature. Thank you, Vijay. Somebody else?
Stock market.
Stock market.
Stock
Yeah, the
market.
stock market data. Excellent. Thank you, Pravin. The other guys, this is your time to say something. Agriculture, talk of agriculture data, weather data, all those. Now, the next thing is, yeah, budget data. Thank you, Ramaswamy. Then the next thing is, what do we do? What do we need to do with it? This one I've covered slightly. What we need to do with the data. It helps in policy and planning situations. And then now, this is now the crucial part. I was happy last time when Prem shared some challenge on WhatsApp on forecasting the COVID situation in the country. And that is where now most of you actually came up with so many methods. That was impressive. That was impressive. So when we say how can we do that, someone can say, I'll go the route of the deep learning. Another person will say, I'll go the route of the normal modeling, the time series modeling like ARIMA. Another person will say, I'll go the route of maybe LSTM. I'll go the route of, all these are correct actually. The only thing is when we do whatever we are going to do with these models, we try our best to do the due diligence that is required for every model. Because sometimes you might say, for example, maybe ARIMA is not good in forecasting this, but it's not good because you didn't consider what is required to be done before you do forecasting using ARIMA. Or for example, let's say if maybe you are supposed to do data scaling, but you forgot to do that, then you might end up saying the model is not very good. Or think of any AI method that you can think of. And it is nice actually, during your free time, especially now during this lockdown moment, try as many models as possible. And remember, we say you can never exhaust knowledge. And you are a lifetime student. You keep on learning every day. So whenever you come across a new model, get to learn about it. And then once you realize there is something good in this model, tell your friends, tell your classmates, try it out. It can always be published. Remember, I've told you, any work, any study that is done without being published is as good as it was not done. So whenever you do and you see some progress, share with your colleagues, because you can never be perfect in everything. You can never know everything. Your friend will be able to know. You might know the first bit. Another colleague might know another bit. Another colleague might know another bit. When we put the brains together, we will have a massive power that can change the countries. So up to there, I think I won't take much time. It's almost 1 hour. It's a 1 hour session. So I would end it at that, and then I open the floor for any question that you could be having. Any question that you could be having?
Yeah.
Feel free.
Sir,
Yes, Vijay.
you have used many models, right? Like ARIMA, SARIMA, and all.
Yes.
Sir, which one do you think is better? Does it depend on this data set or?
Yes, yes. So Vijay, thank you for the question. Every model is affected by the kind of data you are using. And I'll tell you this. There are some data sets whereby you will apply this data, ARIMA will do very well. And like maybe, for example, maybe an artificial neural network method. But the moment you change the data, it changes also. So any model is affected by the data that you are using. So that's why I'm telling you, it's good. You do a lot of training initially, so that now by the time you say, wow, out of all the methods I have, the best model in my data set is this one. So it's a matter of playing with it, play with the data, understanding the data until you get the best out of it. Thank you, Vijay. Any other? Feel free, you can ask anything. It doesn't have to be time series. Feel free.
You not even a question actually. You can make a comment about.
Even a comment.
And let me ask you: anybody has tried any time series data in data science students? Have you tried the modeling any time series data? I think Prem has given some data, no, for COVID data, and who did it, Prem?
Yes.
Like time series.
So most of them has done that. I
Mhm.
think Praveen has done,
Mm.
Anandu has done, and then Arya has done.
I see. Arya, tell Arya. Arya is there? Like Arya is there? Tell what kind of the model you use. Is Arya over there?
Not me. I'm
Arya, tell. Please tell. No, don't hesitate.
I have done. I haven't done something.
That's not very clear. Can you tell again?
Okay.
What did you use, Arya? Which model?
I haven't done something. Not me. I'm
Anando.
Uh,
I did not get you fully well. Okay.
It's not clear. Or you can type on the chat.
Yeah, or chat box you can type. The audio was not very clear.
Dennis, can you? I have a question.
Yes, yes.
Can you
Yes, ma'am.
explain about the Kenyan stock market? You have done doing some project on Kenyan stock
Yes.
market. So it's
Yes.
it's like time series forecasting, something like that.
Yes. Actually, what we are working with that student is an MSc student. He wants to forecast the stocks. So we are looking at we are using the LSTM method to forecast. So yeah, so we are still working on it. And in due time, definitely I'll share the results so that at least we get to learn together also.
Yeah.
Yes.
I'm also interested in the stock market and to identify some seasonal patterns. In some
Yes. Yes.
stocks, there will be some seasonal patterns, and if you
Yes.
identify that, it will be some
Yes.
interesting case studies. Like for
Yeah. Sure.
Avid, then I will
Yes.
get
And
more details.
another dimension would be to make a paper or research paper or something, is to
Yes.
compare Kenyan stock market and Indian stock market and see the
Excellent. Excellent.
similarities and divergence. How it is different and how it is similar. Like in what aspect is similar.
Yes.
So
That's very true.
hmm?
I hope the master students do they do a project
Yeah, they
before
do
they complete the course?
6 month project is there, like 6 months.
Excellent.
Also,
Excellent. Then they can even consider looking at something like that.
yeah.
I will
So,
facilitate the data from this side.
mhm.
Yes.
So
Nitin has asked, can we use categorical data in time series analysis? Yes. Yes, we can. You know, in when you talk of categorical data, these are data we normally collect mainly using the Likert scale. For example, let's say you ask some people how they are, whether they are satisfied with maybe a product, then you tell the person in a range of, say for example, 1 to 5, rate the service that we've offered you. That's what we mean by categorical. And then now when you come to the components of two categories only, that's where we normally talk of now the binary. It becomes binary. And in that case, if you were to model a binary dependent variable on other predictor variables, we normally consider logistic regression. So logistic normally does very well when you are modeling a binary dependent variable. So it's very possible. It's very possible to do that. I hope I've answered your question, Nidin.
Ramaswamy has asked us about situations we may use qualitative data.
Okay, Ramasan, which situations we may use qualitative data? And when it comes to qualitative, these are the data now, they are not quantifiable. Take, for example, you ask someone to give their comments on the kind of service they've received. You know, people now will write whatever they want to write or type. That's normally what we mean by qualitative. But what normally happens mainly, uh, we normally categorize, because if you do let's say you do a questionnaire, for instance, to collect qualitative data, at some point we normally find a way to categorize them. So maybe out of that qualitative data, you normally find someone says, okay, you go through the comments that someone has given, then you say this is a negative comment. You can categorize it as maybe a negative, and then if it's a positive comment, you can assign something, maybe a 2 or a 1, depending. Then you can still analyze that comfortably. I hope that's okay, Ramaswamy. It's possible.
And I have a question, like, we talk about the panel data. How these techniques now, this ARIMA, these, will it be applied to panel data? Like, panel data, to my knowledge, has several components, right? It's not one series. For example, every time point you measure 3 quantity, like. So it is a 3 times is put together, like. The panel data. Is there something different from this?
For the case of the time series, that one I'm not very sure. But for the case of
they call it as a panel data.
Yeah. So for that one, I'm not very sure about the ideal way to handle that. Yes.
Then another thing is, for stationarity and non-stationary, people say with the unit root. What does it mean, like now?
Unit root actually we normally check because normally when you have the raw data, we normally say it's not stationary, because take for example stock prices, they'll just be increasing. It has a trend. So when we normally do what we normally call it the trending, you remove the trend, you expect the data to be stationary.
Right.
So stationarity means in this case is when you plot the raw data, you see the trend. The moment you subtract the mean, for example, and then you plot it, now it will fluctuate around 0. So we say it is stationary data. So we normally use now the unit roots. There's a method we call it the Decay method.
What is that? Unit root means is the root of some polynomial or something. What is that root means? I did not get.
Yes, we normally use it to measure the stationarity of the data. So if it falls within a unit, we call it a unit root, because if it's a radius, so if the value falls within, that's how we talk of it as a unit root, then it qualifies for stationarity. If it is outside, then it's not.
Okay.
So we normally, those are the things we normally check. Like for ARIMA, the D components normally helps us in differentiating the data to help it become stationary. So sometimes you find D of 1, that tells you the data was stationary when it was differentiated only once. Sometimes you find a D of 2. It means it had to be differentiated twice for it to be stationary. Then now normally stationary data normally are better when you are modeling. That's why ARIMA will do that internally without even knowing. And then the I in ARIMA will now do the reverse to give you the real value. Yes.
Okay. So anybody, any comment?
Anybody else?
Aparna, what do you want to say? Aparna.
Sir, why is LSTM better for time series analysis?
See, this is what Dennis I am asking. I have to call. Then they will have nice questions. If I don't call, they will. If they call by name, they will ask. So the others I will not call. Others should ask. Not even a question. If you have a comment, also you can say. Thank you.
Comment.
Thank you, Aparna, for the question.
Thank you, Aparna, for that. I won't say it is better. Every model has its own benefits and or advantages and disadvantages. So, and again, I'll state this: performance of the model is dependent on the data you are applying on. So sometimes you might apply stocks, and then you realize LSTM is doing very well, but we are not saying ARIMA is not good. Sometimes ARIMA might do better. So it's a matter of data dependent models. The data affects the models a lot. Thank you, Aparna. I hope I've responded.
Yes, thank you, sir.
Aparna, I have a question, Aparna. This question is to Aparna. Actually, don't get scared, because you asked something. I'm asking question like. See, if Aparna, you asked LSTM is better for why it is. Then he said, so it depends upon the data. I mean, for one set of data, maybe one model may be good. In another data, another may be good. So my question: how do you select it? Aparna, do you have any guess actually? So suppose Aparna has a set of data, like one time series, and you want to decide whether to apply ARIMA or LSTM or some other. How do you decide, Aparna? You have any insight, any suggestion? It may not be correct. You tell something. It may not be correct. How do you decide which model you
Actually,
want?
I think maybe when we are using, if for example, when we are focusing on stock market forecasting, we take a long duration data of long duration. So I
Okay.
think we use LSTM based on.
No. Then
I'm
you
not
have
sure,
long,
sir.
uh, long. It may be long duration, but how do you decide which data, which model is good? You have, suppose you know you have a program, computer program for LSTM. You have a computer program ARIMA. You have a computer program some other. You apply all this. It will predict. Each model will predict different values. Then how do you know that which one is good and which is the best model for this? Do you have any insight? Do you have any? How do you do? I mean, if somebody asks. No, why I am asking you, this must be beneficial to other students also. Like, how do you decide which model is good? Do you have any suggestion? Yes, Aparna? Yeah.
Yes,
Tell,
sir.
yeah, tell something. Need not be correct actually. Nobody knows everything, right?
Yes, that is true.
Okay, sir. No, sir, I am not sure what.
Or,
See,
let me help you.
Okay,
If
sir.
already you have LSTM prediction and the observed data, you
Okay,
also
sir.
have ARIMA prediction and the observed data.
Hmm.
How can you compare the two so that you say, wow, LSTM is good? Any method?
I think I will look for what I wanted and which shows me that gives me that answer.
wow.
In terms of
Aparna,
the
what
error,
is
I
how do you check
expected
the error?
something like that.
hitting error you can tell now?
Yes, sir.
If
Yes.
hitting error, how much
Yes.
better each model fit with the existing data. So you can find the error, no? The model prediction for the
Yes, yes.
same data, and already you have data like that. No, then you find the error. Then you say this is good. So I mean, another thing is that if you want to forecast future values, what suppose you have 1 year data, you
Okay.
use 11-month data. 11. Don't use the last month data. Use 11-month data and fit ARIMA. Then you predict the next month, for which
Yes.
you already have a data, no? Already have
Yes.
a data. You prediction also, yeah. Then you use 11-month data, predict with LSTM. So
Yes.
you and predict 1 month for LSTM, you for the next month December. Then like that, use each one you predict. Then each prediction may be different, but each one
Hmm.
you can compare with the existing data. No? You already have that data.
Yes, sir. Yes, sir.
Then you
Then
will know the best fit, the best
I will
data.
give the best prediction. Yes, sir.
Yes.
Exactly. Yeah. And but these
Excellent.
may not
Excellent.
be, even this is not a perfect way, because like a
Yes.
still even happens like like COVID and
Yes, sir.
all this will fail. I mean, who knows what is going to
Yes.
happen in the future?
That is true. Yes. Especially the chaotic behavior in the COVID data is a lot.
Yeah. But this is the only thing you can do.
Yes. At least actually what we are saying is do at least what you can do.
Yeah. Do what you can do.
Yes.
This is very philosophy. Okay,
Yes.
Abhirami did in statistics, no? Abhirami, do you hear? Abhirami, do you hear?
Sir,
Okay.
I have a
Praveen, yes, yeah, please.
so, when we are applying time series on a data like stock market data, there may be events like political events occurring at that time in the country. So this may affect the stock market, but the data regarding that is not in our data set. So how do we account such events in our model?
Thank you, Brabin. You see now that is now where the error component comes in. The more the noise in the data, that will if the model won't be able to capture that, it will go to the error term. So definitely the prediction will be affected a lot. So it's a matter of assessing again the adequacy of the model. You check all those factors. Is the fitted, because again, when it comes to fitting models, there is something we call it overfitting a model and underfitting a model. So at the adequacy stage where you are checking whether the model is adequate to do that job, if it's overfitting, I want someone to tell me why are we against overfitting in the data? Why are we against overfitting in data analysis? Anybody having an idea? And when I talk of overfitting here, in other words, the model has learned the data 100%. It can explain 100% of the variation in the data. Why is it not good for forecasting? Someone? Somebody?
Yeah, please respond. Please respond. Whatever you guess, need not be correct actually. You don't worry about your answer is wrong or anything. Nobody knows perfect everything correct.
Yes. Even me, I'm learning.
You're all learning. Today, actually, I learned one new thing actually. What Denny said, usually more data, the better. Like, I never knew that for time series, that is not true actually. It never occurred to me. This is for the first time I'm hearing it. More data, the better. Because you have more data to train the model, right? So it is always good. But he says for time series, it is not like that actually. So that is something which I learned today. I haven't heard of it before that. Something we learn every day. Like what is wrong with that? So you take this up and
at least something new. Something new.
I don't. You want to make any comment or question? I don't. Are you here? Do you hear me? Yeah, Vijay.
Yeah, Vijay.
Sir, in this overfitting, I think the reason is because overfitting works like it works better perfectly for the existing data, but for the next data or future data, it becomes very unpredictable.
Excellent, excellent. In other words, the model has mastered the data you gave it to fit. The moment you give the data which is not within what you modeled, it's likely to do or give you a very wrong forecast. So that's why we normally lie in between there. If you get a poor fit, then there's no need of even going on, because if the fit is very poor, the error is a lot, that tells you no need of using that model. But if you get at least reasonably, we normally say reasonably good fit, but not overfitting, then that can give you now reasonably good forecast when you go out of the sample that you've considered. We normally call it the out sample forecasts. But for the in sample, overfitting will give you excellence. In other words, if you are to give one predictor, the dependent variable will be exact. That is what we call overfitting. But the moment you give anything outside, it deviates. So that's the thing. And that also answers the question Brabin was asking, the issue of the political cases. If there is overfitting and then there is a political situation, then it will affect totally. So those are things. That's why before we do any forecast, we consider the EDA. We normally call it the exploratory data analysis. By the time you get there, you've studied the behavior of the data, be it using the visuals. You plot them. You see, do you have the seasonal components? If is this a purely random data? You see, something like that. You study all those things. That is the stage of checking for we call it the EDA. So I hope I've answered Brabin.
Yeah.
Yes, sir. Thanks.
Okay. Thank you, Brabin.
Okay, nice talking to you all. Any other comments?
So otherwise, thank you so
Sir,
much.
I have a
Yes.
Yes, Rick.
so hi Dennis sir. So
Yes.
you just mentioned about comparing the models by selecting
Yes.
in our time series data,
Yes.
right? So
Yes.
can we do like mean square error model or area under the curve those models to select the better model?
Yes, yes. Actually, that's what we normally use to check which one is the best. And then there's one other way of assessing which models are better by doing literature review. You know, a lot of this work has already been done. So if you're able to go to Google Scholar, search the area you want to check, in most cases you'll find the model you want to work on. Already the
Okay,
details are
so
there.
based on the data, we can see that which
Yes,
model is mostly used,
yes,
right? Yeah, okay.
yes, yes.
Okay, thank you, Dennis.
Yeah, thank you, Sri.
Am I audible?
Yeah, you are.
Yes.
Okay. Good evening, all. We just had a great session with Dr. Dennis. The talk was very insightful and informative. On behalf of Department of Future Studies, University of Kerala, and all the participants here, I'd like to express our sincere gratitude to Dr. Dennis for spending your valuable time for us and also for the insightful talk. I extend my gratitude to Prem sir and our HOD Sadish sir for organizing this talk. Also, I would like to thank all the participants for their active participation. Thank you.
Thank you, Arya.
Fine.
Yeah, thank
Okay,
you
see
so
you.
much.
Dinesh.
Thank you.
Yes.
Thank you.